All right, welcome back to the regular expressions presentation for this Linux admin scripting course. And to be sure, 9 out of 10 developers agree that this is the worst topic in all of programming. This is one of those things where you're going to need it about once every 6 months, and by the time you need it again, you're going to forget everything you learned the first time. So it is essential that you are able to read the documentation, interpret, and then be able to execute on a particular thing. Okay, so this presentation is going to be a relatively long one, and most of it, don't feel bad if you don't fully grasp it. We're not going to go over any examples for this lecture because it's going to go on for a good minute. If you're a Alfred State student and taking this class in person, we will be going over this in class a significant amount, and then there's a lab on it as well, so you'll get a little bit of practice in. But I cannot stress enough that the amount of times that you use regular expressions, by the time you need it again, you're going to forget what you learned when you used it 6 months ago, a year ago, or even 2 years ago. Okay, so with that said, keep that in mind and do the best you can interpreting all of this. And it's one of those things that you just got to get through, right? Get the thing, get it done, make it work, and move on with life. Okay, so with that said, let's get into this, and it's going to be a long one. Okay, so regular expressions. From now on, I'm going to say regex for short. That's how everyone else pronounces it and talks about it. So we're going to start using that term called regex. Okay, regex allows you to search for strings based on patterns. Those patterns are generated by a series of symbols, and this is part of the reason why it is difficult to learn, because you're taking something that is something that you already know in real life as particular symbols, and you're completely converting it to something else. So this is why a lot of people struggle. This is why a lot of developers that have been in the field a long time hate regular expressions or regex. Okay, so all following expressions have one or more of the following things: a char set. So if you're looking for a particular character, you can look by those characters. An anchor, okay, or a modifier. Okay, we'll get into what those mean here as the presentation progresses, but just understand that you have to have one of those three things to be a regular expression. Okay, note that regular expression engines are different for most languages. Okay, so there are a handful of regular expression engines out there, and depending on which one you're using, will have a different result for the regular expression you have. So if you get on Stack Overflow and you take a regular expression and it doesn't work, you're going to have to possibly deal with the fact that the engine that you're using isn't the same as what that person was trying to use or answer the question to on Stack Overflow. So that's, again, I'm not a fan of Stack Overflow for a variety of reasons, and that is one of them, where you're trying to take answers from other people that are not answers to your question. All right, so keep that in mind. If something doesn't work and it seems that it would work and you got it from a different resource that wasn't what you generated or what you learned in this course, just be aware that it might be the regular expression engine itself. All right. Each language should support the same core features. Okay, so your anchors and modifiers and char sets, those are going to be the same. It's going to be how they apply them are going to be a little bit different if you run into that problem. If there are problems, consider the differences between regular expression engines. Okay. Bash tools. Now, the first thing I got to say is that Bash is going to return an entire line if it finds a match. So this is not super helpful from my experience, unless you are going through something like a log file or something like, oh, password D would be helpful for that, where you need to get a particular user, and I think it's this, so I'm going to use regular expression to give me everything that I think it is. That could be helpful, but other than that, I almost universally use Python for regular expressions. But we do need to go over the bash tools, just because there are scenarios out there where you're going to bash makes more sense to use it than creating an entire Python script just to do regular expression. Okay, so we have grep, a very simple way of matching text, still uses regular expressions for that. Sed offers it's grep plus a little bit more functions, so it transforms and substitutions as well. Again, entire line, so be very careful with that. And AWK, which is the example that I'm going to be using throughout this presentation, which is grep and SED with more features. It's more, obviously it's the most feature rich, still single line. So if you get a match and you replace it, you're going to be replacing that entire line, okay? Char set search. This is by far the easiest thing that, in terms of regular expressions, you can possibly do. So you're quite literally just looking for strings, okay? So if we come down here, we have a dot, which is anything but a new line. So this is your wildcard. You have A or B right through here, okay? Oh. You have your range, if you have a square bracket here, A, B, C. So range is A to C, all right? Here, not A to C, right? So we got a modifier here. That's what this is called. We'll go over more of those here in a minute. A modifier essentially saying take my strings and negative, not these things, okay? And then a common search or common char set search is this right here. Capital A through Z, lowercase a through Z, and then 0 through 9, all letters and numbers, okay? So example 1 with AWK, we are searching for / to say this is the start of a regular expression or a regex, all right? So we've got a square bracket, so we're going to do a range, capital A through Z, lowercase a through Z, and then we have the global flag here, okay? So what the global flag is going to do is state that we want as many matches as you possibly can get. So if we didn't have this global flag here, it would find a character that would match this and it would stop. So you'd get basically the first line. So the content here is, this is a test, right? So you get back this entire line because it matched this T here and return that entire line because we're using AWK, okay? The rest of this is error, so AWK is going to give you back a 1 or a 0. So based on that, you can tell the user if there's an error or not, if they found anything, okay? So this script returned the entire text file, and this is every line, okay? Example 2, okay? So now we have file, we're looking for file, the string of file, and then we're going to print the results, okay? Same logic down here for the error, and then the only line that came back was this file, text in a text file, and matched this string right here, and it returned this entire line. Hopefully that made sense. Okay, meta characters. So we already went over wildcard, which is right here. / escape a meta character to make it a literal. So if you want to search for an IP address and you needed this dot, well, you'd need a / in front of this dot to search for the IP address. If it was 192.168. You'd have to have backslashes to make sure that that dot is considered a character and not a wildcard, okay? /T is tab, /R is return or enter, depending on who you're talking to. /N is a new line. These square brackets is any type of range, so char set or numbers, okay? Again, we went over this. This is a common one, all letters and numbers, and then this, a modifier, not a pattern, okay? Shorthand. So once you get your feet under you, you'll start using these shorthands quite a bit. So digit, word, white space, and then everything over here that is capital is not a negative. So not a digit, not a word, and not white space. Regular expression modifiers. So this is not a modifier. I was wrong. Meta character, all right? My mistake on that. And again, guys, this is the type of thing, one, it's one of the topics I know least about, but two, it's one of those things that you're not going to use very often. You're going to forget those little details, okay? So make sure you have a good reference around that you understand, so when you do need regular expressions or regex, that you have something close by that you understand. Okay, so regex repetition modifiers. So we have star. All right, 0 or more of the last character, and we'll get into a few examples of that. 1 or more of the last character, or 1 or 0 of the last character, and then question mark, plus, and the star, respectively. Okay. Example 1. Notice that we have a plus here. So we have 1, 2, 3, 4 plus, so 1 or more of the last character, which is this 4. Yeah, strings of 1 or more of the last character. That should have been a 4, so this is coming up as a 5. Oh, because of number. So number. We got 1, 2, 3, 4, 5. All right. And then AWK is 6, 6, 7, and then we have string following 0 or more. Again, it's a reference for me. 0 or more here. So we got another 7 here, and then we got another 8. All right. This one, 6, 6, 7 question mark, which is going to be 0 or 1. We got another 7 and 8. So let's go make sure I'm right here. 0 or 1, okay, of the last character. All right, so we got a 7, and then we got an 8. Okay, quantified modifiers. Okay, so we can do min and max like this. So notice that we have our curly brace here, all right, and every single one of these. So min and max, a number, and then a number. Okay, you can expand these. So I'm doing a shorthand for digit here. I want 5 through 10. I want the digits 5 through 10 in whatever location this is, whatever your regex is. Okay? If you don't want a range and you want to say, I just want to find the next 5 digits, backslash digits, and then put a 5 here. Okay? And then if it's 5 or more, you do backslash D for digits, and then 5, comma, with nothing, and that would be 5 or greater. All right? Greedy expressions. Standard repetition quantifiers are greedy. So what we mean by this is that it's going to match as much as possible before giving back a result. Okay, so this might matter depending on what you're looking for. And if you need control over what you're getting back and what you're trying to substitute, then you need to know that this exists. So greedy expressions are your standard repetition, but they're going to return as much as possible. And basically what that means is it's going to keep matching until it doesn't have a match, and then it's going to return everything that it found. And hopefully that made sense. Okay, so we got an example here. We have 2 things that equate to the same result. So if we start here, we have a wildcard, we have 0 or many, right? So a wildcard of everything, and then we have 0 through 9, and then we got our global flag here, okay? So this matched all of these, and then if we took away the range 0 through 9, it still matches all of these. And the reason for that is because it essentially equates to the same thing, except for this over here is going to match everything. This over here is only going to match this syntax here, because it's going to go wildcard, 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 and then, oh, a number. Okay, I can give this away now. So now we're at numbers, and we're going to give this away. Lazy expressions, okay? Alternate repetition quantifiers are lazy. They will match as little as possible before handing off to the next expression. So if we come back here, this would quantify as a lazy expression. I'm going to match until this one can take over. This is going to be a greedy expression because it's going to match all of it. Same thing with it. So the exact opposite here. So I'm going to give you that example over here. As soon as, and you can force a lazy expression here. So as soon as this wildcard doesn't match 0, 1, wildcard match, wildcard match, wildcard match, wildcard match. Space. As soon as it can give this matching, as soon as this matches this little bit right here, as soon as it gets there, as soon as this matches somehow, it's going to hand it off. And that's why you're getting this result right here, where you're only getting that first number. Okay, so something to be aware of, right? Lazy expressions in Python, so basically the same thing, except for we don't have the space here, and we get this result, which is the same thing that we were showing, for the same content at least, we were showing on the last pages. Okay, find all, so we have our wildcard here, 0 or many, question mark, 0 to 1 for whatever your last character is, and then we have our 0 through 9, and then 1 or more. So that's going to give us this result here. So if I take away this plus, we get this result. Okay, so this is, if you get something like this, this is a natural lazy expression type of problem. So we have page, so we got all of these. This is going to match all of our string here, and the space, oh, sorry, question mark, which is going to be the last character, which is the space, and then it's going to hand off to 0 through 9, which is going to get that 1. And then it's going to move on to the next character, which is 2. Matches that wildcard, which is 3, matches the wildcard. Okay, so when you get this type of a result, it's probably because of a lazy expression. Okay, now if we wanted to fix that, we could give it a space, and then we can give the numbers 1 or more. So if this ended up changing, say this was 1,946 pages, this would still match, and we'd still have this control over the space. So this is a little bit better formatting, and you're going to get a lot less false positives this way. Grouping. All right, grouping is kind of how you would expect it. It's one of the few things in regular expressions that is kind of intuitive. So we have our open parenthesis and closing parenthesis. Anything inside of that is going to be done first. So order operations is exactly how you would think it would be done for normal programming. Okay. So an example of this, a simple one, is I'm going to look for this group ABC 1 or more times. So it's going to match both of these sets of searches. It's going to get repeating ABC, and then it's going to get a single ABC as well. So this is a little bit more helpful for when you're looking for something along the lines like this. If I need to know how many times someone was mentioned, and then they had different titles as well. Okay, well, return to me, Dr. space, Evan, space, Inky. So what this is saying is, does it have doctor, question mark, 0 or 1? Does it have a space, 0 or 1? Does it have Evan, 0 or 1? Does it have another space, 0 or 1? Does it have Inky? It has to have Inky for it to be a match. So any flavor of these combinations plus the last name of Inky is going to return me a match. Now the problem is that if, say, Inky's wife was in this particular article or particular file, that's going to count as another matching return. So there's probably a better way to do this, but I think it shows a good example that regular expressions tend to bring back false positives and false negatives. But with that said, this is part of the reason why no one likes this. It's very difficult to deal with, and it's very hard to get exactly the right thing. So let's show you that example. So we got this going on, which is the exact same search from the last page there. And then it returned us these things. Okay, Dr. Evaninki, Aninki, no error, and awk. All right. So this is where we start getting into why we needed Python to begin with. So let's say that we needed to manipulate some of these results. Well, getting back an entire line isn't really going to help us unless you are manipulating a, say, password D file where you just need to change the username of someone, okay? If that's the case, then yeah, okay, go ahead and use one of those bash tools and you're going to be okay. But for basically anything else, you're going to need Python. So here's the scenario. We have grouping repetition in Python. This is to demonstrate that you can get a very similar result. This is giving us back all of, find all, of course, but we got doctor, space, space, space. So this is a positive return, a natural space, empty string, inky. Okay, so that's a positive return, and this is an array, square bracket, and where is it? There we go, square bracket. So this is a good example of, okay, yeah, we use the exact same search parameters, actually not exactly the same, I don't have my one here, the exact same search parameters, and we got back something very different because we used a different tool, like Python. So to get back to my original point here, sometimes you need to replace something that is based on a position of that match. So right here's a good example. If we have numbers, like phone numbers, inside of a text file, and it's not encrypted for some reason, well, maybe we need to at least try. And then we can do something like this. So we're going to open up the file. We're going to read that file. We're going to convert that file into a string. We're going to close that file. And then RE, which we imported up here for regular expression, replace. Your first parameter is your search. So we're looking for digits. We need 3 of them. And then we're going to add that dash over here. And then we're going to replace it with star, 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 dash. And then we're going to give it the string that we just converted, which was up here. And that gives us this result. All right? Hopefully that made sense. Anchors. So occasionally you're going to need these. Just make sure you know that they exist. And everything with regular expressions is going to pretty much fall under this umbrella. You're not going to memorize it. There's too much complexity. Just have a regular expression cheat sheet handy with you and then work your way through it. Now, this is not an easy process. This is not one where it's just like, oh yeah, this is totally easy. Let me go ahead and do this. No, this is one of the things where you're gonna do an expression. You're gonna think it works. You're gonna go through your testing, and then you go, okay, yeah, I got a false positive or false negative, and then you're gonna have to fix it. So it's a very procedural, iterative process when you're doing regular expressions. So anchors, start of the string line, okay? $, end of a string line. \a, start of a string, never at the end of a string. \z. And to be clear, I've never used \a and \d, but they do exist. End of a string, never the end of the line. Okay, \b, word boundary. So here are your word characters. So not a word boundary. Sometimes you need these, okay? I needed this before, I've needed this before, and I think I've used that once. Right? It is, again, cheat sheet, and work your way through it. It's an iterative process. Iterative process. I can say that better. Anyways, anchors example. First word needs to be, obviously, letters. So we got that anchor down here. We got this. And then anything after it. And then last word, this. String, as many as we need, \, dot, end of the line. So we're looking for a period at the end of the sentence for this one. Good. Hopefully that made sense. Okay, obviously that was a large amount of information and you haven't even practiced it yet. That is okay. If you're an Alfred State student, we will most certainly be practicing this. And with that said, if you're not an Alfred State student, I should say, if you're having problems with this, I'm going to help you as much as I can. Just understand that I have my own academic curriculum, and then I have this job as well. So I'll help you where I can and what time I do have, but this is one of those things where I can't help everyone. So with that said, I will see you in the next video.